Hi students, this is our 5.4 lesson on completing the square. So our learning goal is that we can restructure a conic section equation by completing the square. And we're going to focus on quadratics during this section. So if I asked you to look at this first equation and find the vertex, first of all, I'm hoping that when we see that squared, we know we have a degree 2, which indicates a quadratic function. So we would have a parabola. This parabola would also open down because of the negative a value, or the leading value here. Now, for the vertex, we would look for a horizontal shift found in here of -7 and a vertical shift of +1. And that would be our vertex. So if you're a little bit rusty, here is the equation we want to look at. These are on your flashcards from the beginning of the year with all the different function types as well. And HK is your vertex. Now, if I ask you to find the vertex for this equation, y equals x squared plus 4x minus 6, it's not in this form. So it's not as easy to just pick out HK from this equation. However, if we complete the square and write part of this as a perfect square, we could actually find the vertex that way. So we're going to learn how to do that today. All right, so for the criteria for success, you're first going to write the equation in standard form. All the terms are on one side, and the other side would be equal to the y or whatever the other variable might be. You want to make sure that you have, so in this case, y equals, you want the x squared term, then the x term, and then the constant. Okay, if one of those terms is missing, obviously you wouldn't have anything to put in that spot, but you want them to be in descending order. If the a value is something other than 1, you do need to factor that out, which we'll practice. You also want to determine the value that will create your perfect square. So we'll use the area model to show this. And then we need to make sure we balance the equation. So if you add some new value that creates a perfect square, you need to subtract it on the same side of that equation. And then finally, you can identify the vertex. So we're going to do several examples. Okay, so for this one, go ahead, write this question down, and obviously pause me at any time so you can catch up and absorb and see what questions you still have. This a value is 1, so we can start in right away. So what we have here is we have x squared plus 4x, and I usually just put a space here and then continue with the rest of the equation. We're looking to find out what value could I put in place here that would create a perfect square. So if we think about factoring, that x squared would go here. This is the number. I don't know what it is going to be yet. That's what I need to find. And I also know that the diagonal has to add up to that 4x. Okay, so this is like a little mystery we're trying to solve. We have the x times x. That's my only choice there. And I have 4x here. So let's split that in half. 2x and 2x certainly would add up to 4x. What would have to be right here? Well, what times x is 2x? That's a 2. And for here, x times what is 2x? Oh, that's a 2. To find out this missing little square here, we would say, okay, so it's 2 times 2, which is 4. Notice what we have. X plus 2 times itself. That is a perfect square. So what we're going to do is we're going to input that plus 4. We can't just start adding up random numbers and putting random numbers in here. So we have to balance this equation. So if we add 4 here, then we're unbalanced. But if I write that minus 4 here, now we're balanced. I added 4 and I took it away, but notice I took it away on the edge here. because I don't want to mess up what I have here, which is my perfect square. X squared plus 4x plus 4, if we look at the yellow highlighting here, is the same as x plus 2 times itself. Perfect square. Minus 10. And I just went ahead and combined those. We have now completed the square. The vertex is -2, -10. We are changing the way the function looks, but not what the function means. So if you go ahead and you take a graphing calculator or Desmos and you type in, and I'd like you to try this, type this one in and type this one in, and you should get identical graphs. The only difference is the way that it's written. Okay, let's keep going. All right, complete the square and state the vertex. Okay, same thing here. Notice we have the 1, so we can go right into here to figure out that special number. So y equals x squared minus 5x, and then I'm going to try my highlighter again, something, I don't know what that is, plus 11, and then remember I need to take that something away. So I don't want to forget so that I can make sure I'm balanced. X squared is here. X and x are my only options. Remember the diagonal is the same here as this -5x. Okay, so what do we think for this? This is a little trickier. Let's split this in half. So that would be -5 halves and -5 halves. Together, if I added those two together, I would get -10/2, which is -5. Okay, and of course we would need the x with each of those. So all I did is I took this middle term and I cut it in half. So how do I get -5 halves x? Well, this is x times what? -5 halves. And this is x times what? -5 halves. So let's think about what this is going to be. Well, it's -5 halves, these are the dimensions, times -5 halves. That is 25/4. It's kind of gross. We got a fraction here. It's a little bit gross, but it's going to be just fine, so don't worry. And so we can say, all right, to complete this square, we must add 25/4. And we can't just randomly add numbers. If we're going to put something else on the right side, we need to also take it away from that side. So I'm going to say at the end here, I'm going to minus 25/4. Okay, and now you're like, oh my goodness, we need to factor this. The good news is we already did. That's your perfect square. So we can say y equals x minus 5 halves quantity squared. And then plus, so for this one, we would have 11 minus our 25/4, which would be 4.75. So your vertex is going to be positive 5 halves, which is the same as 2.5, no rounding needed, because we want exact values, and then comma 4.75. So they can get messy, but remember, you're always going to be able to complete that. There's a special number for all of these that will create the perfect square. All right, let's take a look at one that does not have an a value of 1. So this is actually in your packet. Page 16, there's A through D. There's 4 to try. So let's do this first one together, and then you can either go along with me and do the other ones together, or you can check the key that I'm going to post in your classwork folder. All right, so this is where things get a little crazy because this too is an issue. So I am going to look at my first two terms here, and I am going to factor out that leading coefficient. And I'm going to leave my space for whatever completes my square. And then don't forget, we got to undo that over here. Okay. So now we're dealing with this, where we've taken out that a value of 2, and we can go right into our box again. So now we're kind of back to what we started with, the x squared with an x and an x, the only choice. That's minus 10x. So if I cut that in half, that's negative 5x and negative 5x. Now I ask myself, x times what is negative 5x? Negative 5. X times what is negative 5x? Negative 5 again. These should be identical. We are creating a perfect square. So for the final part here, this square here, this is what we're interested in, this missing little number here. Negative 5 times negative 5 is 25. And that is the number that will complete our square. So we say plus 25. Now here is going to be the part where lots of students make a little mistake here. Some of you are going to want to write minus 25. And you're like, well, yeah, because I added 25. I want to undo it over here. However, what we really added is 2 25s. 2 times 25 is 50. So you need to have minus 50 to balance. This is tricky, okay? So pay attention, take your time with this. If you take something out here, that greatest common factor, you need to be very careful when you do your undo step over here, when you balance. All right, so let's write this. Y equals 2. Now remember, we said it's this x minus 5 times itself. That's the factor, x minus 5 quantity squared. And then we take 45, take away 50 is minus 5. So my vertex is 5, negative 5. Okay. There are 3 more questions on page 16. I would love for you to give those a try. You can stop watching and just check on the key that I posted, or you can stay with me or just pause me and see how far you can get and then, play me on double time, whatever you want to do. But I'll just keep going along and solving for those of you that would like some more guidance with this. I see that this a value is not 1. So my first step is to take that out, and that's going to be 6x, and I leave my space. So I need to find the special value that completes the square. So let's go to my area model. X squared goes here, x and x. We know the diagonal is 6x. So I'm just going to chop that in half. 3x here and 3x here. The way to finish this top right, it would be what times x is 3x? Well, that's a 3. And x times what is 3x? That's a 3. 3 times 3, that's this, 3 times 3 is 9. So plus 9 is the piece that I'm missing. Now please remember, we didn't just add 9. We added 45. So to balance, we need to subtract the 45. Y equals 5. What does this factor into? Look at our box. We already got it. X plus 3 quantity squared. That's the dimensions. That's a perfect square. Plus 3. And so the vertex is negative 3, 3. Okay, let's take a look at equation C on page 16. Once again, we got to deal with this a value, so let's go ahead and pull that out. Notice I'm only pulling it out of the first two terms. You're going to be doing that same thing. I keep that minus 3 the way it is, and then I make sure to write down my two blobs here so I don't forget to complete the square and to balance. Okay, let's take a look. So x squared is here. Diagonal is going to be negative 4x. X and x. Let's cut that negative 4x in half. We get negative 2x and negative 2x. Negative 2 and negative 2. So that means our missing little value here is 4. So we add 4. We really didn't just add 4. It's getting trickier and trickier. Negative 4 times 4 is negative 16. So we need to say plus 16. Okay, so we have y equals, again, now our work is done. Now we're just going to rewrite it. We've already factored this into a perfect square, which is quantity x minus 2 squared. And then negative 3 plus 16 is 13. So my vertex is 2, 13. Okay, last one. Here we are again with that a value that is not 1. And let's go ahead and factor it out. So we have x squared minus 8x. Leave our space. Let's put in those placeholders so we don't forget. Okay, and let's go to our area model. The area model is not required, but it is a nice way to be able to show structure to your work. So, man, I do not like the way that looks. Okay, so that's x squared here. This will be negative 8x. This has to be x and x. We cut the negative 8x in half, negative 4x, negative 4x. Remember that these two spaces have to be the same because remember, we're trying to make a perfect square. That's why I cut these in half, because now we can just say negative 4 and negative 4. And then this missing value we were trying to find, positive 16. So we're going to add 16. Now we didn't really add 16. It's 6 times 16, which is 96. So to balance that positive 96 that we didn't have before, we're going to take it away on the same side. So y equals 6. We've already put this in a perfect square. We look to our area model. X minus 4 times itself, which is x minus 4 quantity squared, minus 3. And so my vertex for this parabola is 4, negative 3. Okay, we'll definitely practice more of this. Sit with this, write down questions, and we will look at this together in class.